So the first problem just asks us to integrate this, and so we add 1 to the top number to the exponent, and then we divide in front by that same exponent and add c at the end. So most of you should have been able to get this without even doing 2 steps, using your regular power antiderivatives. And that's your answer for problem number 1. For problem number 2, we're just taking the antiderivative of this problem, but we're not allowed to take the antiderivative when it's in this form. So what we need to do is we need to make this 5x to the third divided by the square root of x minus 3x over the square root of x plus 2 over the square root of x. And remember that the square root of x is the same thing as x to the 1/2 power. So when I divide this is really 5x to the 5/2 power minus 3x, 1 minus 1/2 is 1/2 power, plus 2x to the negative 1/2 power. So in each one of these problems, each one of these terms, when I take the derivative, I add 1, and I have the reciprocal in front. Let's see, this becomes 3/2, so I put 2/3 in the front, and then this becomes 1/2, and so I put 2 over 1 in front. So when I got this, I got 10 over 7, x to the 7/2, minus 2x to the 3/2, plus 4x to the 1/2, plus c. And there's your answer for number 2. So for this particular problem, we need to take the antiderivative of the right side to give us x cubed minus 4x plus c is equal to y. So now we plug in the number, so 4 is equal to y, 2 cubed minus 4 times 2 plus c gives me 4 equals, when I plug this in, we get 0 plus c, which means 4 is equal to c. So my answer is going to be y equals x to the third minus 4x plus 4. For this next problem, I need to multiply this out. Before I do anything. So we got 4x squared minus 20x plus 25 dx. When I take the antiderivative, we get 4/3 x to the third minus 10x squared plus 25x plus c equals y. Now when I plug in negative 3, 7, so 7 equals 4/3 times negative 3 cubed minus 10 times negative 3 squared plus 25 times negative 3 plus c. All of this is just numbers, so we put it into the calculator. So 7 equals negative 201 plus c. So we're going to add the 201 to both sides to get 208 equals c. So my final answer is y equals 4/3 x cubed minus 10x squared plus 25x plus 208. Alright, so we have our first definite integral, and a reminder, we're going to change this to be 1x to the 1/3 plus 2 dx. So we got 4/3 here, which means this is 3/4 plus 2x from negative 1 to 3. So this becomes 3/4 times 3 to the 4/3 plus 2 times 3 minus 3/4 1 to the, sorry, it's a negative 1 to the 4/3 plus 2 times negative 1, and that's in parentheses. So this turned out to be 9.24 minus, I should put a 5 in there, 3 decimal places, minus negative 1.25, and it turns out to be 10.495. For problem number 6, we want to take the antiderivative of the cosine of x, which is the sine of x, and we're going from 0 to pi over 3. So we got the sine of pi over 3 minus the sine of 0. So going through the unit circle, the sine of pi over 3 is the square root of 3 over 2 minus 0, which means my answer is the square root of 3 over 2. For problem number 7, we're doing the second fundamental theorem of calculus, which basically means when we take the antiderivative and then we take the derivative, there's not much to do, and we get the answer. If we were doing from x cubed to the sine of x, the square root of t dt, we are going to do the square root of the sine of x times the derivative sine of x, which is the cosine of x, minus the square root of x cubed times the derivative of x cubed is 3x squared. And there's my answer. Alright, for this problem, I'm going to do this with u substitution because I think that I meant to put an exponent above the parenthesis. So when I take the derivative, I got du equals 6x. So we got the antiderivative of 6x times u times du over 6x. The 6x and the 6x cancel, so we have the antiderivative of u, which is 1/2 u squared plus c. And of course, we plug back in the u to be x squared minus 7 plus c. Alright, so this time I'm going to make u equal to 3x, which means du dx is equal to 3. So we got the sine of u times du over 3. So basically we have, since nothing canceled, 1/3 the sine of u du. The antiderivative of sine is negative cosine, which means when I change this back, I got negative 1/3 cosine of 3x plus c. Alright, so this time we have a definite integral, so I'm going to make u equal to 2x minus 3, which means du dx is equal to 2. So from 2 to 4, not from 2 to 4 anymore, we have u to the 4th times du over 2. But when I plug 2 in here, 2 times 2 minus 3 is equal to 1. So the 2 becomes a 1. And 2 times 4 minus 3 is equal to 5. So that becomes a 5. So we got from 1 to 5, u 1/2 u to the 4th du. So when we take the antiderivative, it's 1/2 times 1/5 u to the 5th from 1 to 5. So 1/10, and then I'm just going to plug it in, 5 to the 5th minus 1/10, 1 to the 5th will give us our answer. And that gives us an answer of 312.4. Alright, in problem number 12, u is going to be equal to the sine of x, because that's the one that has the exponent. Du dx equals the cosine of x. So, u squared times cosine of x times du over cosine of x. And the cosine of x cancel. Now the sine of 0 is equal to 0. And the sine of pi over 2 is equal to 1. So this is really going from 0 to 1 now. So we got 1/3 u cubed from 0 to 1. 1/3 1 cubed minus 1/3 0 cubed gives us an answer of 1/3. And that is it for this particular review.